Hey, I got a great lesson for you today. Parallel lines and transversals. Neat relationships on what's going on here when we get a transversal on parallel lines. First, you should know that parallel lines, they never intersect, and we always think railroad tracks. So there are your parallel lines. A transversal is a line that intersects two or more parallel lines. So this line that I just drew in purple is a transversal because it intersects my parallel lines. Congruent, same size, same shape, and same measurement. So if something is congruent, if one angle is 20 and it's congruent to another angle, then that other angle has to be 20 degrees. So what's cool about this lesson is that parallel lines, they form many angles, and the relationships you see with these angles are really neat. At least I think they are. It's because I'm a math nerd. So for instance, let me remind you that supplementary angles are two angles that if you add them together equals 180 degrees. They make a straight line. So if I would add the measure of angle 1 plus the measure of angle 2, that would equal 180 degrees. Good to know. Now in this example, I'm asking you to name the parallel lines. Well, M and N, you need to look for like letters on lines. That's how you identify them. So I would say M is parallel, that's the symbol for parallel, to line N. So that's how you would write it mathematically. And then name the transversal. Well, the transversal is the line that intersects two or more parallel lines. So line P is the transversal. That's it. So let's look at some relationships that are formed. The first one that I'm going to talk about are vertical angles. And if you think vertical, even if your line is in a different direction, it's a straight line vertical. So vertical angles are congruent. Here is your symbol for congruent. It's a squiggly over an equal sign. That means the same measurement, same size. So looking at our examples here, if I look at angle 1 and angle 4, they share the same vertex, and I could put a straight line here. So therefore, angle 1 and angle 4 are congruent to each other. So angle 1 is congruent to angle 4. Likewise, 3 and 2, I share the same vertex there. Is that a straight line? The answer is yes. So angle 2 is congruent to angle 3 because they're vertical angles, and vertical angles are congruent when you have a transversal cutting parallel lines. Pretty cool, right? And I could go on with 5 and 8. They share the same vertex. They are congruent because they are vertical angles, as well as angle 7 and angle 6. So angle 6 is congruent to angle 7. So vertical angles, congruent. Next one I'm going to talk about is corresponding angles. Corresponding sounds like a big word, but if you think same location on a different parallel line. So for example, if I'm looking at angle 1 here in pink and angle 5 here in pink, they're on a different parallel line, but they're in the same position. So angle 1 and angle 5 are in the same position on the parallel line in respects to your transversal. So they are called corresponding angles. And all corresponding angles are congruent because that's what happens when you have a transversal cutting parallel lines or intersecting into. So angle 1 is congruent to angle 5. And you can go on with these same relationships. Angle 2 is in the same position as angle 6 on a different parallel line. So angle 2 is congruent to angle 6 because they're corresponding angles. Angle 3 and angle 7 are in the same position on different parallel lines, so they are congruent to each other. And then lastly, angle 4 and angle 8 are congruent because they are corresponding angles. So we have vertical angles are congruent, corresponding angles are congruent. Alternate interior angles, they are also congruent. What this means is, break it apart. Alternate is on, think opposite, like opposite sides of your transversal. So looking at angle 4 and angle 5 here, and I'm looking at my transversal P, that transversal P, angle 4 is on the right side of this transversal, angle 5 is on the left side, so they're on opposite sides of my transversal. So that's what I mean by alternate. So opposite sides. Interior is, if you're thinking like here's your railroad tracks, and I'm just going to do just part of the line here. In between, like where would that, what's in between the tracks? Where shouldn't you walk if a train was coming? So in between, inside. So angle 4 and angle 5 are both inside this area of those two lines on opposite sides of my transversal. They are alternate interior angles, so they are congruent to each other. Same measurement. Likewise, I have angle 3 and angle 6. Opposite sides of my transversal P, but inside, in between my parallel lines. So angle 3 is congruent to angle 6. So we've got vertical angles, corresponding angles, alternate interior angles are congruent, and the last congruency one I'm talking about is alternate exterior. Again, alternate opposite sides of my transversal. So left side, right side. This time exterior, think outside. So outside your parallel lines. So here's your parallel lines. So I'm talking about this area outside. Nothing in between. Outside my parallel lines. This is my exterior. This is my exterior. So looking at my angles in relationship, I've got angle 2, which is outside of my parallel lines, M and N, and it is on one side of my P. What matches up on the opposite side is 7. So angle 2 and angle 7 are congruent because they are alternate exterior angles. Pretty cool, huh? Number 1, or angle 1 and angle 8 are both outside of my parallel lines, and they are opposite sides of my transversal P. Left side, right side. So they are also congruent because there are alternate exterior angles. So now we're going to talk about same side interior. Same side is also known as consecutive. So consecutive interior. Depends on who writes the question. Same side, consecutive interior angles. Means the same thing. So obviously same side is, if you have your transversal, they're on the same side of your transversal. So same side, and then interior again is in between your two parallel lines. So if I'm looking at angle 4, it's in between my parallel lines. Here's my transversal P. What is on the same side? Angle 6. Now note here, they are not congruent. They equal 180 degrees because they are supplementary. So not congruent. Angle 4 plus angle 6 equals 180 degrees. Angle 3 plus angle 5 is 180 degrees. So angle 3 plus angle 5 equal 180 degrees because they are same side or consecutive interior angles. Boy, you're learning so much in this lesson. Keep up with me. We're almost done. So same side exterior. This is the last one I'm going to talk about before we practice. Again, same side. I'm talking about a transversal. So they're on the same side of my transversal. Exterior, they are on the outside of my parallel lines, not in between. So they are also supplementary. In other words, they also equal 180 degrees. So angle 1 is outside my parallel lines. What is on the same side as that outside? Angle 7. So angle 1 plus angle 7 equal 180 degrees because they are same side exterior. Likewise, angle 2, angle 8, they are outside, same side of my transversal. So if I add them together, they are not congruent. Not congruent. They equal 180 degrees. So let's practice and see what we learned. If we know the measure of one angle, we can find all others based on the relationships of angles we just talked about. So the measure of angle 1 is 120 degrees. There are multiple ways to do this. I'm going to do several along the course of these two examples to get you used to seeing them. So angle 1, well, if I just want to go right to angle 2, well, angle 1 and angle 2 form a straight line. Straight lines have to equal 180 degrees. They're supplementary. So 120 degrees plus something, which is my measure of angle 2, has to equal 180 degrees. So to find x, you subtract 120 degrees from both sides, and you get x is 60 degrees. So the measure of angle 2 is 60 degrees. So if you need to pause this, go ahead. I'm going to erase that and put my 60 in. So the measure of angle 2 is 60 degrees. I'm going to put my 120 back here for 1. So let's find the measure of angle 3. Let's use same vertex, straight line. What do they form? They form vertical. So I'm talking about angle 2 and angle 3. Vertical angles. Vertical angles are congruent. So if 2 is 60 degrees, 3 has to be 60 degrees. Well, that was pretty easy. If 1 and 4, same vertex, I could put a straight line here. They're vertical angles then. Vertical angles are congruent. So if 1 is 120 degrees, 4 has to be 120 degrees. So those are some relationships we're going to talk about. So let's talk about other relationships on finding the measure of angle 5. Let's use angle 4. If I told you angle 4 and angle 5, again, there's multiple ones you could do. But angle 4 and angle 5, they are inside my parallel lines on opposite sides of my transversal, left and right. So they are alternate interior. Angle 4 and angle 5 are alternate interior angles. They are congruent. So if 4 is 120 degrees, 5 has to be 120 degrees. And let's use that for 6 and 3 as well. Alternate interior angles. So 6 has to be 60 degrees because 3 is 60 degrees. That is just so cool. So I'm going to do another example here. I'm going to leave my 3 as 60 degrees and look at angle 7. Well, angle 3 and angle 7 are on the same side of my transversal, but they're in the same position on different lines. So that makes them corresponding angles. So angle 3 and angle 7, I can't do two things at once, are corresponding angles. And guess what? Corresponding angles are congruent. So if 3 is 60 degrees, 7 has to be 60 degrees. Let's look back to see what angle 4 is. That is 120 degrees. Angle 8 and angle 4 are also corresponding angles. So 8 has to be 120 degrees. Again, you could have found them using vertical angles. You could have found them different ways. I was showing you how to relate to both of these different scenarios that I've talked about so far. More than both of them. But one more example before we recap. I know the measure of one of the angles, so I can find all of them. So angle 1 is 72 degrees. Angle 6, and I'm jumping here, angle 6 is my vertical angle, so 6 has to be 72 degrees because vertical angles are congruent. So angle 1 plus angle 2 form supplementary angles. If I add them together, they have to equal 180 degrees because that's what supplementary angles equal, straight line. So 72 degrees plus something has to equal 180 degrees. This is my measure of angle 2. So I subtract 72 degrees from both sides, and that gives me 108 degrees. So the measure of angle 2 is 108 degrees using supplementary rule. So angle 2 and angle 5, what type of relationship is that? What type of angles are they? They share the same vertex, vertical, V, straight line. So angle 2 and angle 5 are vertical angles. So if angle 2 is 108 degrees, angle 5 has to be 108 degrees. All right, let's look at angle 1 is 72. What is the relationship between angle 1 and angle 3? And you can turn the computer if you need to, or turn it to see it. Remember your parallel lines here are Z and W, and your transversal is X, so it's going in a different pattern, a different way, but angle 1 and angle 3, if I'm looking at in relationship to the green line, the transversal, and they are in the same position on different parallel lines, what type of angles are they? Corresponding. Corresponding angles are congruent. So if 1 is 72 degrees, 3 has to be 72 degrees. Angle 8 is vertical angle to angle 3. That has to be 72 degrees. And I want to use one more rule on finding angle 7, even though we could have used many different ones. So I want to talk about the relationship between angle 6 and angle 7. So let's get the other ones out of our minds right now. So let me just do it this way. Angle 6, we said, was 72 degrees. And the relationship from angle 7. Now extending my parallel lines, because their line goes on forever, in purple here, my Z and my W, my parallel lines there. Remember my X, my line X is my transversal. So looking at the relationship between 6 and 7, they are in between my parallel lines, so they have to be something interior, and they're on the same side. So angle 6 and angle 7 are same side, or our other word is consecutive. interior angles. Consecutive interior angles, same side interior angles, have to equal 180 degrees. So 72 plus something equals 180 degrees. And doing the math the same way that we did last time, subtract 72 from both sides, and we get 180 minus 72, which is 108 degrees. So that is how you find your missing angles. Again, you could have done this, well, this is vertical angle, so 108 here. So there's just multiple ways you can do this. I just showed you examples on how to get some relationships. So in recap, there are 4 congruent angles. We have vertical angles. We have corresponding. We have alternate, and I'm going to abbreviate here, interior angles. And we have alternate exterior angles. These 4 angles are congruent. So that relationship of angles, the measures are the same. What is supplementary or 180 degrees? Well, we have the first one, which is supplementary. And again, I'm going to abbreviate. They form a straight line. We have same side or consecutive interior angles, and I'll put interior here, interior angles. And then we have same side exterior angles. These 3 relationships, those angles together, have to equal 180 degrees.